All right, so we want to be able to graph with a restricted domain. So we start off the same sort of way. Here I've got a linear graph. So in order to graph it, I need a y-intercept and an x-intercept, or at least they're the things we generally find because they're the nice things to find. So y-intercept is when x equals 0, so y equals 2. X-intercept is when y equals 0. I think I said the wrong one for the first one. So that one equals -2. So right there we have our points. So if I was going to graph this linear graph, he would look something like that. But the thing is, this isn't a normal straight linear graph. It has a restriction. It says we're not going to care about anything for x that's below -1, that's a bad -1, and above 3. So I don't care about this bit of the graph, and I don't care about anything up there. That bit left in the middle is the only thing I want to graph. So let's draw him in again. But the thing now, I can't just do my graph like that. I need to know what these endpoints are. I know their x value, but I don't know their y value yet. So I need to sub those x values into my equation to figure out the entire point. So that's one of my points. And that's the other one. And then I can label those points. Last thing I need to do is make sure, well, when I've got a curve at open bracket, that is an open dot. Square bracket, closed dot. And that's how we graph with domain. So there was a worksheet, but I haven't uploaded it, and we're in chapter 6b, questions 2 to 6, but I have a quadratic example of the restricted domain as well. So here, graphing a quadratic, same vibe. We need our y-intercept, which is when x equals 0. So that's 1 point. Then we need our x-intercept, which is when y equals 0. So that's just going to use the null factor law because it's already factorized. So therefore, x equals -1 or 3. So those are our points. Oh, shivers, that was bad. And then we need our turning point. So that's going to be halfway between my x-intercepts. So -1 plus 3, which is 1. Then sub that back into the original equation to get out what my y value is, which equals -4. So we have this point as well. But then we have our restricted domain. So we also need to find those endpoints of our graph. So our endpoints are going to be when x equals -2 and x equals 5. So we're just going to sub those values in. So x equals -2, y equals, which is -1 times -5, so 5. So there's one of my points. And then I do the same, but with x equals 5. So we're just subbing in. So we got 6 times 2, which is 12. Okay, so now we have all the bits of information. It's a lot of information, but we're going to plot it. So our y-intercept is -3, turning points 1, -4. -1 and 3. We're going to -2 and 5, -5 and 12. Alright, so if you draw this in pencil, that's best bet because then you can erase your dots and put them where they should be. So like that didn't work. And also if you forget which dot's which, so I remember here, -2 is an open dot, but I've already drawn him as coloured in. Oh no. It's alright, so we'll just make him an open dot. And don't forget to label all your points. so that we know where everything is. -1. And they should be reasonably proportionate. So kind of give it a little bit of scale, but don't have to write every mark on the axes. So there you go, 6B 207.